All right, so today we're going to be looking at segments and number lines. What we've learned is that the distance between any 2 points on a number line is the difference of the coordinates. And when they say difference, what word should you think of immediately? Pardon? Subtract. That's exactly right. Anytime you see difference, you're thinking subtract. This distance is also called the length of the segment with those endpoints. So here, this is that first one that we did. You had a point at A and a point at B. The distance between those is 8 minus 3, which is 5. If you always take the one on the right first, minus the one on the left, then you don't have to ever worry about getting the wrong sign. If you do left minus right, you'll get negative 5. And distances can't be negative. So we also say that the length of segment AB is 5. Or, and this is there's a bunch of symbols in geometry, and they all make really good sense except for this one. When they say AB equals 5, what they're saying here is, please write this, the length of segment AB. So when you just see two letters like that, they're talking about the length of the segment, or how far apart the endpoints are. So let's find these by subtracting. Okay? Could you, since it's on a number line, just count them? Absolutely. And there'll be some on your quiz on this where you can just count them, but there'll also be some where you can't. And I'll show you an example of that in just a second. So here, the length of AB, B is at -1, A is at -6. We subtract, and we get the distance between them as 5. So let's do the next couple. For BC, B is at -1 and C is at 3. Which one should I do first? The 3, because it's further to the right. So 3 minus -1. That's the same thing as 3 plus 1. That distance is 4. The length of segment DC, well, we want to start with the one on the right, which is D. That's at 7. Minus C is at 3. That is 4. And then the length of CA, C is at 3, minus A is at -6. That's 3 plus 6 is 9. And now I think you see why I did a review of subtracting and adding with integers yesterday, because you're going to be doing a lot of that. Okay, let's go on to page 2. Occasionally I have a student who says, I'm just going to draw a number line for all of them. Like, okay, feel free to spend your time drawing a number line that goes from -74 to +47. Might take a while, right? So here we're finding this JS. Usually we just say find JS, but what do we really mean? We mean find the length of segment JS. Again, that's the length of segment JS. Which one is going to be further to the right on a number line, J or S? I've heard both of them so far. Which way is right? Yeah, J is going to be further to the right. So the length of JS is going to be 47 minus negative 74, which is the same thing as 47 plus 74. So let's see, 47 plus 74, that's 11. We'll carry the 1, and that'll be 12. It's 121. So if it's on a number line and the number line is small and you want to just count, you can do that. That's fine. But there's going to be some where you're not going to want to spend the time to make a number line for them. Okay? It's just too crazy. Okay, some more stuff about segments. Congruent segments are segments that have the same length. So here I have two segments. And remember, when I just write AB, that means the length of segment AB. So the length of segment AB is equal to the length of segment XY. Then segment AB, and this is the symbol for is congruent to. Is the way that you read that. Is congruent to. Those are the worst quotations in the world, but you get the idea. And you may be wondering, what's this little slash mark across these? That's how on a diagram we'll mark that those are congruent to one another. Okay, that's how we'll mark that those are congruent to one another. I'm going to have you write up here in this line right up here. We're going to use the idea of congruent for more things than just segment. In general, congruent objects are the same size and the same shape. Congruent objects are the same size and the same shape. I'm going to give you two examples of things that are congruent. First, we'll do a physical one. So, take your hands, please, everyone. Put them palm to palm. Now, turn them so that you can, see one. Does that one hand, and please don't tell me about your various deformities. Every time I do this, there's someone who's like, I broke my finger when I was 3 and it sticks out funny. Basically, does one hand exactly cover the other? Pretty much. Your hands are congruent to each other within some tolerance. Nobody's are perfectly congruent, right? But they're the same size and the same shape. Bigger picture idea of congruent. So let's say that you believe in something, but you act a different way, right? Let's say that you believe in being honest, but you don't always tell the truth. If that's the case for you, then your belief and your actions are not congruent. They're not the same. And you probably, if your actions are not the same, you may want to consider whether or not you actually believe what you think you do. Okay? So that's the idea of congruent. So with congruent segments are all the same shape, so we don't have to worry about that. We just need to make them the same size. All right, moving on. The midpoint of a segment is the point, so that means there's only one, that divides the segment into two congruent segments. It's got to be exactly at the middle. That's why it's called the midpoint. So here, S is right in the middle. Notice the little slash marks, that's how we're going to mark the diagram. And that's just helpful to you because you don't want to have to go back and read the problem 8 times. Like, what did it say about it? You can just quickly mark the diagram. These two are congruent. So here, S is the midpoint of segment RT. It is the point that divides RT into two congruent segments. Now, since the midpoint lies half the distance between the endpoint, on a number line, the coordinate of the midpoint is the average of the two endpoints. That formula should look familiar to you. You did it several times on last night's homework. M is equal to half of E1 plus E2. If we want to find the midpoint here, we're going to do M is equal to half. Endpoint 1 is 1 plus endpoint 2 is 9. And since we're adding, the order doesn't matter on those. You can do right plus left or left plus right, doesn't matter. So that's half of 10, which is 5. So 5 is where the midpoint would be. What's the distance from 1 to 5? 4. What's the distance from 5 to 9? Those distances are the same. This segment from A to the midpoint is the same size as the distance from the midpoint to B. Those two segments are congruent. All right, let's do a couple of example problems. So here it says H has a coordinate of -12 and R has coordinate 7. We want to find the coordinate of the midpoint of HR. I don't require a diagram on these. You can do it without pretty easily. If you want to make a diagram, that's fine. I don't put all the little marks even. I just go H is at -12 and R is at 7. And we want to find the midpoint. I'll call it M since it didn't give me a name. I'll put a little slash across those to show those two segments are supposed to be the same length. So I'm going to use the formula. The midpoint is half of endpoint 1 plus endpoint 2. So the midpoint is going to be equal to half of -12 plus 7. When I'm adding two numbers together and one's positive and one's negative, I take the difference, 12 minus 7, which is 5. And what's the sign going to be? Is it going to be positive or negative? Negative. There's more negative than there is positive. And half of -5 is -2.5. This is the most straightforward way this problem can be. It won't always be this way, but this is the most straightforward that it can be. Let's look at this one, which is not as straightforward. It says A is the midpoint of segment CD. All right, and then it gives us some coordinates. C has a coordinate of 6. And A has a coordinate of negative 14. And it says A is the midpoint of CD. If A is the midpoint of CD, where does D have to be? Where on this number line?
On the negatives?
Yeah, on the negatives, which direction from A?
Left.
To the left of A. That's exactly right. D has to be here. And these two segments are supposed to be the same length. So I'll use my formula. The midpoint is half of endpoint 1 plus endpoint 2. This time I know the midpoint. So I've got negative 14 is half. The one endpoint, I don't know. I'm going to go ahead and just call it D since that's its name. Plus 6. Just like I showed you yesterday in class, I get rid of the 1/2 immediately. I'm going to multiply both sides by 2. When I do that, here I get negative 28. The 2 times 1/2 multiplies together to be 1. So I'm just left with D plus 6. Subtract the 6 from both sides, and we get negative 34 is D. The nice thing about making a diagram on this is that you can see if your answer makes sense. Let's say you messed up somewhere and you got an answer of negative 8. You're like, that doesn't make any sense. D has to be over here, right? So I think a diagram can be helpful, but it's not a requirement. Okay, questions about that? Okay, then I've got a worksheet for you. If you want to go ahead and move your desk back, you're welcome to do that.